Hey everyone, so we have notes today, and the notes is about finding area of parallelograms. So this is lesson goal 212. Go ahead and write that down. And first, let's just define what a parallelogram is. It's just a four-sided flat shape, and these are two important properties of a parallelogram. The opposite sides are parallel, and the opposite angles are congruent. So if we look, and then here's two examples of parallelograms. So if we look, this line and this line, these are the opposite sides. Those are parallel. Okay, and parallel just kind of means they run in the same direction. Imagine a parallelogram. It's like a square. You see, it's like you had a square, and you took it and you just kind of smushed it. Right, you kind of moved it. That's what a parallelogram is. And then again, here's just some examples of parallelograms. And then the area of a parallelogram, the area formula is pretty straightforward. It's just base times height. They don't call it length and width because it's different here. Because there is no like horizontal and vertical measurement always. Well, at least in the parallelogram, there's not like that side. One side is slanted, so they don't go with length and width. They go with base and height. Okay, and I don't have those measurements in there, but you could always think of a base as one of the straight lines. If there's ever like a flat horizontal line, I always call that the base. And then the height is a line that runs perpendicular or straight up from the base. It can't be slanted like these are slanted, but this goes straight up. So the height would be from here to here. Okay. The height, you can think of it as the distance between the two parallel lines, like this parallel line and that parallel line. That's the height. A lot of times in the diagrams, the height is, you can find it by looking for this little square. That just means the height and the base are 90 degrees or perpendicular to each other. But just look for this in the height. Okay. So let's move on. And then we have some examples here. Now it's going to be hard. It's going to be hard for you guys to draw A and B. If you can, try to draw it in. If you can't, don't worry about it so much. I didn't even draw it in. I printed something, but I'm gonna try to do something different with you guys on this one. But definitely drawing these two. Okay. Let me go ahead and do C and D, because C and D tend to be the easier ones. So the area, again, remember the area formula is just base times height. Okay, so the area, and then again you want to figure out which one the base is and which one is the height. Imagine if you took this one and turned it sideways like this, then it's flat. So I would say this is the base, and then this guy is the height. And then again, the height goes straight up and down, not slanted like these lines are slanted. So then the area would be, I'm going to call this the base and this the height. So the area would be 3 inches times 7 inches. And remember here, multiply the 3 and the 7 to get 21. Inch and inch makes inches squared. So that would be 21 inches squared. Okay. And then this other example, D. Again, sometimes the height isn't inside the parallelogram. In the diagrams, you can find the height outside the parallelogram. Again, I would call this one the base, and this the height. And the base, because this one is horizontal or flat, and then the height has to be going straight up. It has to be going straight up. And even though it's not inside, like this distance is the same as this. So that's the height. So area is base 11 yards times height 10 yards. Multiply 11 and 10. You get 110 yards and yards makes yards squared. So again, those are the easier ones. Oh well. So let's do these. Now these, remember, these, if you can count the squares, just go ahead and count them. But see, then we run into some issues where some of the squares used and not all of it. Well, the idea here is to use this trick. Watch. See this part of the parallelogram? Imagine if we cut that part of the parallelogram and then moved it over here. If we did that, now our shape is pretty much a rectangle. It's pretty much a rectangle, and then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. There's 32 squares there. Okay, so that's what the area is. The area is 32. And I don't have a measurement. Imagine, let's just go ahead and call 1 square equal to 1 inch, because that's what it's going to be on the worksheet. So then this would be 32 inches squared. Okay, and again, all we did was count these, but we took this piece and moved it over. You take. Imagine. Because remember, I said it's like a square. It's like a square or a rectangle, and then they just shift it. That's what a parallelogram is. So if we straighten that guy back out, see, then it's just a rectangle, and we can count up all the squares. Okay. So same idea for B. I'm going to use the 1 square is 1 inch. That should be 1 inch squared. Okay. So then this one had 32 inches, so let's figure out how many inches this one has. And again, the issue is, see how like part of this square is filled in, or like it's inside the parallelogram and part of it's not? You're not really sure, like you can't say, oh, this is 1 square, and then this is like 1/4 of a square or 3/4 of a square. So what you want to do, imagine you have that part, right? Imagine when you cut it and move it over to the other side. So it's not here anymore, but it's over here. And then now those little squares get filled in. And then you can just count these. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 30, 40, 50, 60. There's 60 squares. And each square is 1 inch squared. So the area for this guy would be 60 inches squared. Okay, so again, this is one method. Whenever you have to count the squares, you're going to take the parallelogram and make it into a rectangle, right? And then you can count them. Same thing with this guy. See, it goes from there to over here. And then they're both rectangles. Alright, let's do this side.